Hello, ladies and gentlemen. We're going to learn how to graph parabolas using a completely new method today. I wanted to review the one that we've done before so that I can compare it real briefly to what we're about to do. If you remember last week, what we did was we took a look at an equation and we tried to make some predictions about it. We then made a table of values, we plotted points, and we connected the dots. We're going to be a little bit more sophisticated today using the symmetry of the function in order to help us plot special points and then reflect them over the axis of symmetry today. So if you recall with a graph like this one, we would look at that and we would kind of ask ourselves these three questions. Is it skinny or fat? And we would say this one is skinny because it's got an a value of more than 1. Is it concave up or concave down? This would be concave up because a value is positive. And then we would look at it and say, is it shifted at all, up or down? And in order to see that, we would look at the C term, and we notice that our C term is a -5. So in this case, we are shifted down 5 units, which brings our vertex location down 5 units to the point 0, 5. So once we had those predictions, we could take a shot at just picturing that in our head, and that's just our mental check so that when we move to the next step, making a table of values, plugging them in, getting our outputs, and plotting our points, we can at least make sure that our predictions match what we actually got for our graph. Okay. Now today we're going to do something just a little bit different. I've got a different function over here, and what we're going to do is we're going to find the axis of symmetry. Last week I showed you a diagram of a parabola with an axis of symmetry labeled. Today I'm actually going to give you a formula so that you can figure out where exactly that axis of symmetry is. So once you have that, you're going to go through and plot just a couple points. I'm going to try to help you figure out which points to plot precisely. In this case, the axis of symmetry ends up being here, and I'm not sure if I'm plotting these in the correct spot or not, but what we're going to do in general is that we're going to plot a certain number of points, say those 3 points right there or so, and what we're going to do is we're going to use the fact that this is symmetric to basically just reflect those points over onto the other side of the graph, and then we'll have a nice, smooth, continuous curve, in this case of very large smiley faces. And we will get our 5 points by only actually figuring out 3 of them. So here's the process. I think we should pause the video so that we can write all of this down. It is an important process, so pause the video for a moment and write this down. Okay, one of the basic skills that we need to know how to do first is we need to be able to write an equation for a vertical line, because all axes of symmetry are vertical lines, and on the tests and on the quizzes they're going to ask you for an equation for the axis of symmetry, and you have to write an equation for the axis of symmetry and not just know. So if you remember, a vertical line is x equals some number and nothing more. Okay, so this one, the x value is on the x equals 3, so the equation for this vertical line is x equals 3. What I'd like you to do, just to remind yourself, to refresh yourself, is I'd like you to write 3 equations, each one for each of these remaining vertical lines. Pause the video for a moment and get that done. Okay, if you've done that correctly, this was probably the trickiest one. That's right smack on x equals 0. This one's x equals -6, and that one's x equals -4. The reason I had you do that is because it's going to be extremely important to have a good grasp on what an axis of symmetry is. And each time you find one, you're going to have to write an equation for one. So we just have to become very familiar with, or very comfortable with graphing or writing an equation for a vertical line. So what I'm going to do here is I'm going to find all the different components of this formula right up here. I'm going to find the axis of symmetry, the y-intercept, the vertex, and one other point so that we can graph this equation right here. According to that process that I had up on the last screen, the first thing we want to do is find the axis of symmetry. That's the heart of the parabola. Everything's symmetric about that, so it's a really important area. And I'm going to show you how to derive this formula perhaps later, but for now, all you need to know is what the formula is. And this will give you your equation for a vertical line just by following the formula. It says x equals the opposite of b divided by 2a. You may want to pause the video again so that you can write this down. The way this formula works is this b and this a go right along with the same coefficients that we've been dealing with these quadratic trinomials here. The a is the term in front of the x squared, the b is the term in front of the x, and c is the constant term. You'll notice that c doesn't play into this at all, so you only have to know your b value and your a value. The only tricky part about this formula is that it does have a negative sign or an opposite sign built in. So whatever your b value is, in this case -8, you're going to take the opposite value of that. So what I'd like you to do right now is I'd like you to see if you can use this formula and write the equation for the axis of symmetry right now. Pause the video for 30 seconds, see if you can do that. If you've done that correctly, just substitute in -8, so you have the opposite of -8, which would be +8, divided by 2 times 2, which is 4. So you got 8 divided by 4, which is 2. So your equation for your axis of symmetry is x equals 2. Okay, that gave us this line right here, this line that cuts our parabola perfectly in half. Now there's something else that's special on the axis of symmetry, and that is that the vertex occurs on the axis of symmetry. So we would really like to have that vertex. It is also a minimum or a maximum value always. So that is a very, very important point for many applications that we use parabolas for. So the next point is to use this axis of symmetry that we have for our vertex. The good news is our axis of symmetry in this case is x equals 2. So that means we know the x coordinate where our vertex lies. So we know without a shadow of a doubt that our vertex is on the line x equals 2, which means that we know the x coordinate for it. And all of these functions that we're getting are input an x, output a y. So we have the x to input into here and it will output our y. So if all we have to do is basically let our x equal the axis of symmetry, just plug it into the formula, and it will kick out a y value that tells us how high the vertex is. So if we take our axis of symmetry here, and in this case x equals 2, and we're going to pop it right back into the function, we just substitute it in. We have 2 times 2 squared minus 8 times 2 plus 3 equals y equals 5. So that means I plugged in 2, I got out 5. That sounds like a coordinate to me. So basically the vertex is at 2, -5. So we figured out where our line of symmetry is. We knew our vertex was on that line. We used our x coordinate to figure out how high our vertex was. And we have it. So we have our axis of symmetry and we have our vertex. The other point that's pretty important to us is going to be our y-intercept. And just like the axis of symmetry, we also know the x coordinate there. The x-coordinate on the y-intercept will always be 0 because the y-intercept is always on the y-axis. So we're going to use kind of the same trick again, but instead of letting our x equal whatever our axis of symmetry is, we're just going to let our x equal 0. So if we do that, in any of these functions, if I put in a 0 for x and a 0 for x there, we got 2 times 0 and -8 times 0. So those are both 0 and they just cancel out. That will always happen. It will always cancel out your a term and your b term. So the cool thing about finding a y-intercept is you can basically just ignore everything else in the formula and look at your c value. That will be your y-intercept. It'll just be 0, comma, whatever your c value is. In this case, 3. So our y-intercept in this case will be 0, comma, 3. If you don't believe me and you just want to work it through a little bit, just let x equal 0. Those two things equal 0. You get input 0, you get out 3, so you have the point 0, 3. Okay, so we've done a lot of work so far. We found an axis of symmetry, a vertex, and a y-intercept. So let's start drawing this stuff. So I'm going to grab my line tool here, and I'm going to draw in, the first thing I'm always going to draw in is my axis of symmetry, because I know that that's the middle of my parabola. That's where everything is going to reflect about. And then our vertex gave us a coordinate and our y-intercept gave us a coordinate. So I'm simply going to plot those 2 points. I'm going to go over 2 down -5, and I'm also going to plot my y-intercept, which was 0, 3. Now, here's the cool part, is I know that everything is symmetric around this axis of symmetry. It's not symmetric around this, it's symmetric around my axis of symmetry. So here I have a dot that is on my line. If I reflect that, it's not going to change positions. This one, however, if I reflect this over the axis of symmetry, so I look that's 1, 2 units away, I can reflect that 1, 2 units away, and I can put a second dot right there. And I get a free dot, which is fantastic. Unfortunately, I still don't have 5 points. Now, I said that to graph a parabola, you have to have 5 points always. So we have to look at this and figure out where would we like another point. And a good spot to be would be somewhere around here. I'm betting our parabola opens upwards, so I'm betting that there's a point to be had somewhere around here and somewhere around here. So what you're going to do is you're going to use your best judgment and choose an x value that's going to help you out. So in this case, it looks like if I choose an x value of x equals 1, or find the point on the line on the curve that is at x equals 1, I can get one more point out of the deal. So we have to get one more point so that then we can then reflect that one over. And I said x equals 1 would be a fantastic decision. Okay, so let's plug in 1 for x and see what happens. If you do that, you get this 2 times 1 squared minus 8 times 1 plus 3 equals -3. So I have another point that I can plot at 1, -3. So I can plot that point right there. And automatically after plotting that point, I can reflect it immediately over my axis of symmetry and get my second point. And again, I'm no good at doing this on a computer, but I'll give it a shot anyways. We'll connect the dots in a curve. Oh, wow, that's really bad. Curvy fashion, and we'll do a parabola just like that. Don't forget your arrows on top, which are going to be even more gross for me to draw, but you get the idea. You can do that much better with paper and pencil, and as can I promise. But there we have it. We have 5 points. We only really had to find 3 points plus a line of symmetry. This eventually goes a lot faster. Okay, so I want to turn you loose here and see if you can figure out how to do one of these yourself. So I'm going to ask whoever's controlling the video to pause and play between each one of these steps here. The first thing I'd like you to do is find an axis of symmetry. So pause the video, use the formula, and try to find an axis of symmetry for me. If you do that correctly, you'll substitute in -6, you take the opposite value and divide by 2 to get x equals -3. So we can actually draw that in right away. Right there. Okay, the next thing I'd like you to do is find the vertex. Now remember, the vertex will always be on the axis of symmetry. So what you're going to do is you're going to use the x value from your axis of symmetry to calculate a vertex. So plug in the x value from the axis of symmetry and find a vertex. If you do that properly, you get the vertex of 3, 2. So that would be over 3 up 2. Okay, so I am going to go up by 2's on my y scale, and my line will come back in just a moment. The last thing I'd like you to do, or the second to last thing I'd like you to do, is find the y-intercept. Now remember, the y-intercept will always occur when x equals 0. So plug in a 0 for x and figure out the y-intercept this time. Okay, we've got a y-intercept, and we've got our vertex, and we've got our axis of symmetry. If you take that y-intercept and reflect it over 1, 2, 3 units to our axis of symmetry, 1, 2, 3 units more, and put another spot right there, another point right there. The last thing you got to figure out is to find a point somewhere in here that's going to help you get your 5th point. You can choose x equals 1, x equals 2, x equals 4, or x equals 5, and that'll give you 1 point on either side of this that you can reflect. I would suggest small numbers. Go for it. I chose 1, 6, so that'll give me another point right there, and I automatically get that second point right there. Connect the dots in a nice smooth curved fashion, and you've got your parabola. So there's